Okay, we move to the following presentation that will be made by Fermin Alcasena, optimizing the use of prescribed fire for managing wildland fuels in Catalonia.
Okay, thank you, Rosa Maria Canals. Good morning, everybody. Thanks for coming to my presentation. Many thanks also to the organization committee for accepting my oral communication. My name is Fermin Alcasena. I am forest engineer, master in wildland fires, and PhD candidate of the University of Lleida. And in this study, we identified preferential locations to implement prescribed fires within large fire source priority areas in Catalonia. Just to give you some context information, you already know probably that Catalonia is one of the most important fire-prone areas where very few large fires account for the bulk of the burned area. Fuel build-up on landscape, fire suppression policies, and urban sprawl on the last 50-100 years led into high-intensity large fires spreading for large distances, frequently burning as well into wild and urban interface areas. Those extreme fires overwhelm fire suppression capabilities. Field treatments on the landscape mitigate extreme fire spread, and prescribed fires are usually the best cost-effective treatment to reduce forest fuels. This may be the reason why we are here. Since 1998, more than 350,000 hectares have been treated with prescribed fires in Catalonia. In this study, we propose preferential locations for prescribed fire treatments aiming to contain large fire spread, disable spot fires, mitigate risk to the wild and urban interface on large fire source areas in Catalonia. For the identification of fire source priority areas, first we modeled fires across Catalonia. We replicated some 10,000 fire seasons with FCON's minimal travel time command line version of FLAMAP at 150-meter resolution, considering wildfire season, dominant fire weather conditions, and historical ignition patterns. Then we identified the blocks, the municipalities, presenting highest fire activity using a transmission analysis. In this transmission analysis, burnt area polygons were intersected with municipalities, and results were tabulated to assess the net fire exchange as the difference between outgoing fires and entering fires to the municipalities. All results were annualized and normalized per 1,000 hectares to compare the results obtained in the different municipalities. Since we have a huge gradient in fire weather conditions in Catalonia, we considered all these differences in fuel moisture content and wind direction and wind speeds to divide it in 5 macro areas, okay, where we consider in every macro area local fire weather conditions concerning fuel moisture content and wind speeds. We considered the Pyrenees area, macro area, the Pre-Pyrenees and the Prelitoral area, the plain of Lleida and Empordà coastal plain, and the coastal range. Okay, so we considered all this information to replicate burn patterns in Catalonia. Then, to optimize the treatment allocation, we used the Landscape Treatment Designer software. In this optimization process, we considered 3 objectives. When we treat, we want to block major fire pathways. For that purpose, we use the distance to minimal travel time major pathways as the objective metric. When we treat, we also want to disable spot fires. In this case, the active crown fire probability was used as the metric to prioritize treatments. And finally, when we are treating on the landscape, we want to mitigate the risk to the wild and urban interface. Finally, in this case, we use the fire transmission to dwellings in terms of number of structures burned from ignited fires as the metric to prioritize treatments. In this analysis was only conducted on priority areas, where we treated 20% of the forest land. We set a 1.2 conditional flame treatment threshold to identify the treatment polygons. In other words, we were treating only where the conditional flame length was higher than 1.2 meters of flame length. Here in this slide, I will show you the downscaling process we followed from the regional scale up to the stand level treatment allocation. First, we conducted a transmission analysis in the entire Catalonia. Then we subdivided Catalonia into 41 projects, which are the counties we have in Catalonia, the administrative division of the counties. Then inside the counties, we identified priority municipalities, which are the planning units. And finally, inside the planning units, we identified the treatment polygons or stands. And this is the result for the transmission analysis, where we have fire sink municipalities and fire source municipalities. Those fire source municipalities were the high priority areas for the implementation of prescribed fires. Then in the following slides, I will show you the results for one of the counties in Catalonia, for the county of Vallès, which is located in central Catalonia, one of the most problematic areas in Catalonia in terms of large fires. So first, here we have the results for the county of Vallès, where we identified the priority planning units, okay? Then, within these priority planning units, we conducted the optimization analysis to identify the polygons that mitigate most the transmission to buoy, active crown fire, and block major pathways. Here in this slide, I show you the results separately. And then, combining all together this information, we obtain the final result, okay? This is the project, the fuel treatment project for the county of Vallès, where we have some priority units, and inside these priority units, these fire source, large fire source priority units, we identified the polygons, the stands that maximized attainment levels for the three objectives, okay? And finally, to conclude some discussion and conclusions, how many minutes do we have? A lot of time, okay. So in this study was conducted to identify forest stands, polygons between 1 to 10 hectares, okay, for the prescribed fire implementation on a very large landscape. Catalonia is more than 30,000 square kilometers. And the treatments attempt to convert highest fire activity areas on large fire containers, okay? Substantial fuel treatments are required to reduce significantly the large fire spread, but we all know that treatments at these intensities are not possible on the entire landscape. And therefore, we implemented a fire transmission approach to quantitatively assess fire exchange and identify large fire source municipalities. The municipalities that flash fires to surrounding municipalities for the fuel treatment allocation, because as we have seen in the second slide, the problems we have most are concentrated in big, large fires. So we focus our treatments on large fire source municipalities. Then within these priority areas, we maximized attainments for the three objectives. We consider these three objectives. Other objectives could be as well considered. This is up to the manager. And taking advantage of the joint production and treatment spatial collocation, we conclude proposing the preferential treatment allocation. And this is a very important point. Results are provided at management meaningful scale. These results could be easily interpreted by large-scale managers and to conduct the implementation of prescribed fires. We only consider for treatments the forest lands burning above 1.2 meters of conditional flame length. We also understand, this is a very important point as well, that herbaceous fuels management on priority areas, like for instance with sustainable grazing, will substantially improve treatment duration and effectiveness. Other mitigation measures, like treatments on the home ignition zone and risk perception program in communities, should be combined with this study to increase homeowner preparedness and promote fire-adapted communities. Have time? Okay. This is as well very important because with our approach, we are reducing the burn probability around communities, okay? This is the first factor of the risk, probability, but we are not acting over the consequences of the fire, which is the second component of the risk. And to mitigate the consequences, this is the reason why we should combine as well treatments on the home ignition zone and enhance preparation of the community homeowners. Okay, and that's it. I think it was too fast, right? Well, I'm open to any question.
Okay, that's time for questions now. Do you have any question?
Good morning. Michelle Steinberg with the National Fire Protection Association in the U.S. I notice you have references to, well, working with the U.S. Forest Service and talking about the home ignition zone. Is that phrase or that concept pretty well known in Catalonia?
Well, maybe we use different terms, but the idea is the same. It's treating on the community buffer, okay? Maybe they use another name, but it's treating in a buffer. Maybe the buffer is not the same. If we consider, as it is widely understood in the US, I think it's between 30 and 60 meters, I think. Here, maybe there's a lot of people of the Forest Service and firefighters. There's a law, in fact, in Catalonia describing the treatments on the home ignition zone, specifying which is the buffer, which are the treatments. So yes, I think we have the same concept, the same idea, and some data might change. Like the buffer, maybe it's not 60 meters, it's like 45 or 30, I don't know. But yeah, but the idea, I think it's pretty clear, okay? Sorry? Yeah, they've got a law to identify communities on the landscape where the home ignition zone should be implemented to mitigate fire consequences. Yeah.
Davide Ascoli, University of Naples. Thanks, Fermin, for this nice presentation. I was wondering, did you simulate also the leverage of this treatment optimization? And I was curious to know if you did it, to know if it is above 1 or below 1, because, you know, there's a discussion about the leverage of such large treatment at the landscape scale. And in Australia or US, we have a leverage below 1, but other studies in Europe says that we have a leverage above 1. So I wonder if in your simulation you calculated that. Thanks.
Okay, so, well, this is a very good question. I talked to one Australian once, and he told me that they just focus on the communities, they treat really intensively around communities, and they forget a lot about the landscape, because the landscape is huge. So to set the percentage of the landscape that we are treating, to do it properly, we should, I think, do a sensitivity analysis between the treatment intensity and the fire size, okay? I didn't do it. I consider as reference the 20% according to other previous studies. But I understand that from place to place, this should be conducted to set the percentage of the landscape we treat, okay? But here the point is that if we are treating just 5%, 3%, we are doing nothing to contain large fire spread, okay? And if I say that we have to treat the 20% of the landscape, they will tell me that I am crazy. So we attempted to find a way to concentrate our efforts significantly on fire source areas. So I didn't do any sensitivity analysis to see which is the treatment surface that optimize the optimal treatment intensity, okay? And I took as reference other previous studies. I don't know if I answered to your question. You can make it again, or we can talk later. It's not a problem. Okay, thank you.